Today our topic is the Pythagorean theorem, and our essential question is how can I use the Pythagorean theorem to find the distance between 2 points? A little vocabulary for you. We have here pictured a right triangle, and a right triangle is a triangle with a right angle. So that'll be marked here in the corner with this little square, or sometimes they'll just put 90 degrees in the corner. Either one will let you know it's a right angle. The sides next to the right angle we call leg A and leg B. So they touch the right angle. The really important piece, though, is your side opposite the right angle, and that's your hypotenuse C. So it does not touch the right angle at all. It's opposite. Okay? So these play a part in our Pythagorean theorem, which is a squared, so we would take the length here, plus b squared, the length of b, and then it equals the length of c squared. So let's put this into practice. We have find the length of the hypotenuse of the triangle. So right angle, we have a and b are touching that right angle, so we have a squared plus b squared equals c squared. C is our unknown, so that's what we're looking for. So we can replace a with 3, b with 4, and c stays c. Now we just need to evaluate. 3 squared is 9, plus 4 squared is 16 equals c squared. 9 plus 16 is 25, so 25 equals c squared. Now, the opposite of a square is a square root. So to undo c squared, we have to take the square root of both sides. Square root of 25 is 5, so c equals 25. That would be the length of our hypotenuse. Next example is a little different because we're finding the length of an unknown leg. So we're not finding c this time, we're looking for a. So start off by a squared plus b squared equals c squared. A we don't know, so it says a, plus b is 6, so we say 6 squared equals c squared. C is 7, so 7 squared. Evaluate, we have a squared plus 6 squared is 36 equals 7 squared is 49. Get a squared by itself by doing minus 36 on both sides. We have a squared equals 49 minus 36 is 13. Undo a squared by taking the square root of both sides, so we get a equals the square root of 13. Now you can leave it as the square root of 13, or you could get a decimal approximation, which would be about 3.7. Either answer would be correct. Next example, using the given image, find the height of the 3rd story window. So we have our ladder here, which is 50 feet away from the building, or 50 feet long. It's 35 feet away from the building, and we want to know what is the height here. What is this length right here? So first off, let's label our sides as A, B, and C. Start by that C. It's across from the right angle, so 50 is going to be our C, our hypotenuse. 35 we could say is our B, and H we can say is A. So now we can use a squared plus b squared equals c squared, our Pythagorean theorem, and just plug in our values. A squared we don't know, it's our height, that's what we're looking for. Plus b squared, b is 35, so we say 35 squared, equals c squared. C is 50, so we put in 50 squared. Now we just need to solve, so we have h squared plus 35 squared is 1225 equals 50 squared, which is 2500. Get h squared all by itself, so undo plus 1225 with minus 1225. We get h squared equals 1275. Undo the square with a square root on both sides, so we have h equals the square root of 1275. Now, if we're thinking about this, that does not help me understand what the height of the building is. That 3rd story window, I don't know what 1275 square root is. I don't know what that is. That value means nothing to me. So this is when you are going to want to get a decimal approximation, because it'll help us understand how tall that window actually is. So we take the square root of 1275 and we get 35.7. So that is how tall that third story window is. All right, if you flip your paper over, we have one last thing to cover, which is the distance formula, which is very similar to the Pythagorean theorem, except for this time you would use coordinate points. So x1 and y1 would be one coordinate point, and x2 and y2 would be your other coordinate point. So that's where you would get these numbers to plug in into your distance formula. All right, so we're going to talk about how to use this and how to apply the Pythagorean theorem instead if you want. So we have one example. What is the distance between 4, 7, and -3, 9 on a coordinate grid? So if we were using the distance formula, we'd say x1, y1, and x2, y2, very similar to when we're finding slope. All right, so we have two methods. One, we can use our Pythagorean theorem. So I'm going to show you that one first. So to do that, you're going to plot the points on our coordinate grid. So we'd have 4, 7, which would be right here. And then we would have -3, 9, which is going to be right here. All right, we want to then connect the 2 points with a line. So I'm going to make that this red line. Then we want to draw a right triangle. Okay, so to draw that right triangle, we're going to have to make a vertical line and a horizontal line, because those make a nice right angle. Then we find the length of the two legs. So we have, this is a distance of 2. We have 2 jumps. And then here we have 1, 2, 3, 4, 5, 6, 7. So our length of A would be 2, length of B would be 7. And then use the Pythagorean theorem to find the length of the hypotenuse, which would be our red line, which would be right here, that distance between the 2 points. So we would say a squared, so 2 squared plus b squared, 7 squared equals c squared. 2 squared is 4, 7 squared is 49, 4 plus 49 is 53, so we'd have 53 equals c squared. Take the square root of both sides, and we would get c equals the square root of 53. And that would be about 7.2 if you wanted a decimal approximation. So that's how we could use the Pythagorean theorem. We would just graph the points and make that right triangle and then use the Pythagorean theorem. The other way is to use the distance formula. All right? So to remind you of what the distance formula is, it's the distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? So our 2 points, we had 4, 7, and that was x1 and y1. And then we had -3, 9, and that was x2, y2. Okay? So the first step is just to plug in those numbers. So we have the square root of x2, so we put -3, minus x1, which is 4, squared plus y2, so y2 is 9, minus y1, which is 7. And we square that. Then we just evaluate this. So we have d equals the square root, parentheses first, -3 minus 4 is -7 squared, plus 9 minus 7 is 2. We're squaring that. Now we can do those exponents. So d equals the square root of -7 squared would be -7 times -7, which is 49, plus 2 squared is 4. And then we have d equals the square root of 49 plus 4, which is 53. So d equals the square root of 53, which is just what we got before. And then, so the distance would be the square root of 53, which is approximately 7.2. So we get the same answer, whether we use Pythagorean theorem or the distance formula. It just depends on which one you're more comfortable with. So if you're not very comfortable with plotting points on a graph, then I would suggest using the distance formula, because then you won't get the points wrong when you graph them. But if you're not really comfortable with this distance formula, you can always feel free to plot these points, graph it, use the Pythagorean theorem. That's all the notes that I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.